Hello friends, I am Siddharth Mehta. This is the lecture of power system. In previous lecture we studied the exact solution of long transmission line. Now in this lecture we will study the long transmission line interpretation. Okay, interpretation of equation of long transmission line. Okay, at the last equation of previous short note we get two equations that are known as the voltage and current equation for the long transmission line. Okay, that is mentioned here, equation number 8 and 9, but this is the new lecture, so you have to refer the previous lecture to know the what is the equation of 8 and 9, and these both equations are again written by me here. Okay, so these both equations are the equation derived for long transmission line in previous lecture. Okay, this is the Vx, voltage at the x point and current at the x point. Okay, and we are considering that element dx is available at x point from the receiving end, so we already derived this equation of voltage and current. Okay, now you know that this is the trigonometric form of equation, so you can also say that this is the hyperbolic equation of long transmission line. Now we will again modify this equation. We will put the values of cos hyperbolic gamma x and sin hyperbolic gamma x. Okay, you know the equation for cos hyperbolic x and sin hyperbolic x. Here instead of x, gamma x is available. Okay, so now we will convert this sine and cos into its second form. So the equation for cos hyperbolic x equal to ex plus e raised to minus x divided by 2, and for sine hyperbolic x it is written as e raised to x minus e raised to minus x divided by 2. Here instead of x, gamma x is available, so instead of x we will write as a gamma x. Okay, so we will write the equation of cos hyperbolic gamma x and sin hyperbolic gamma x in these values and put into this equation. So we will get first of all equation of voltage Vx equal to Vr. Okay, instead of cos hyperbolic gamma x we will written as e raised to gamma x plus e raised to minus gamma x by 2 plus ZCIR. Instead of this we will write its exponential form in of sine hyperbolic gamma x. So we will derive this equation. This equation is in form of exponential. Okay, now we will separate this each element, okay, and open the bracket. So Vr will multiply by this, Vr will again multiply by this, ZCIR will multiply by these two elements. Okay, so we will get different 4 sections. Now combine the bracket with e raised to gamma x and e raised to minus gamma x. Okay, so e raised to gamma x will come common. Okay, so in counts Vr plus, so okay, here you can see that e raised to gamma x and e raised to gamma x, these two terms are common, so we will take common e raised to gamma x. Okay, so in bracket we will write Vr plus IRZC by 2. E raised to gamma x will come as a common element. Okay, second bracket is related to e raised to minus gamma x. Here you can see that two sections are available in which the e raised to minus gamma x is common. So in bracket we will write as a Vr minus ZCIR divided by 2 bracket close e raised to minus gamma x. This is taken as a equation 3. Okay, now we will put value of gamma. Okay, gamma is represented as alpha plus j beta. Why? Because gamma is complex quantity. Okay, and complex quantity can represent as a real number and imaginary number. So instead of gamma we will put alpha plus j beta, okay, in this equation. So we are putting, instead of gamma we will put alpha plus j beta, where alpha is attenuation constant and beta is phase constant. Okay, this alpha is attenuation constant, it means that it is related to magnitude of wave, and this will related to phase of wave. Okay, so instead of gamma we will put as alpha plus j beta, so we will put as a E equal to alpha plus j beta like this. Now you know that the rule. Okay, you can write this as a this e alpha x dot e raised to j beta x. તમે આ જે છે e raised to alpha plus j beta એને આવી રીતના સેપરેટ કરી શકો. e alpha x dot e j beta x. ઓકે, બોથ આર સેમ થિંગ્સ. ઓકે, બે સેમ જ છે. આ ડોટ ડોટ હોય વચ્ચે મલ્ટીપ્લાય હોય, આધાર સેમ એટલે એડિશન થઈ જાય. બરાબર, એટલે આની બદલે હું ડાયરેક્ટલી આ સ્ટેપ લખું છું. Okay, so Vx equal to this plus this. Okay, so we will get equation number 4. Okay, now we will put again value of cos hyperbolic gamma x and sin hyperbolic x in equation number 2. Okay, this is the derivation of voltage at x point. Now we will convert same equation of current up to this point. Okay, so we have available current as a equation 2. Okay, now we will put instead of gamma alpha plus j beta. Okay, and derive the same equation. So the equation for ix is given like this. Okay, vx માં આપણે જે રીતના cos hyperbolic gamma x અને sin hyperbolic gamma x ને બદલે પહેલા આ ઇનપુટ કર્યું, પછી એમાંથી સેપરેટ ટર્મ્સ કાઢ્યા. બરાબર, પછી આપણે આલ્ફા ગેમાની બદલે આલ્ફા પ્લસ જે બીટા એપ્લાય કર્યું હતું. આમાં પણ તે જ પ્રોસિજર આવશે. બરાબર, એટલે મેં ડાયરેક્ટલી આઈએક્સનું ઇક્વેશન છે લાસ્ટ મળે પ્રોસિજરથી એ લખેલું છે. ઓકે, સો ધીસ ઇઝ ધ ઇક્વેશન 5. ધીસ ઇઝ ધ ઇક્વેશન ફોર વોલ્ટેજ. ધીસ ઇઝ ધ ઇક્વેશન ફોર કરંટ એટ ધ પોઈન્ટ એક્સ. Okay, from that equation we will write the equation for instantaneous voltage. Instantaneous voltage means Vx in bracket t. T means at the time of instant. Okay, so that's why it is known as instantaneous voltage. If you like to find the instantaneous voltage from the equation of previous voltage equation, then it will like this: real in the bracket root 2 in bracket Vr plus Ir Zc by 2 e raised to alpha x into e raised to j omega t plus beta x plus root 2 Vr minus Ir Zc by 2 e raised to minus alpha x into e raised to j omega t minus beta x. Okay, so this is the equation for instantaneous voltage and which is derived from the previous voltage. Okay, now we will study this equation in deep. We see that this equation for instantaneous voltage can divided into the two terms. This is the first term that is related with positive power of exponential. This is plus, and this is the second term. This term is related to negative power of exponential. Okay, that's why we are dividing this whole equation into the two terms, because both have an opposite nature. Because here positive terms are available, here negative terms are available. Okay, now we will study first of all first term. Okay, in first term means this, starting from this root to end to this. This is the second term, starting from this end up to. Okay, now in first term you can see that two variables are available. Okay, so according to variable this first term will change, and we can see that only two variables are available which will change. First is x, second one is t. Okay, x and t. Remaining all parameters are fixed or constant. So first term will change according to time and distance. Here time is represented by t, distance represented by x. Okay, same in second term, it is also a function of time and x. Time represents the t, x represents the distance. Okay, here you have to keep in mind that x represents the distance from receiving end. Okay, now we will study that according to time and x what will change in this term. Okay, as you are increasing the x means distance from receiving end. So as you are increasing the x, okay, then what will happen? E raised to alpha x change its magnitude. Okay, so this wave is known as incident wave. બરાબર, ઇન્સિડન્ટ વેવ એટલે સેન્ડિંગ એન્ડથી રિસીવિંગ એન્ડ તરફ જાય જે વેવ હોય. ઓકે, the wave which will transfer from sending end to receiving end is known as incident wave. Okay, so the definition of incident wave is amplitude of first term is increases and phase will advance as we are moving from receiving end to sending end. એટલે કે આપણે જે ફર્સ્ટ ટર્મ છે એનો એમ્પ્લિટ્યુડ વધે છે ને ફેઝ એડવાન્સ થાય છે ક્યારે, તો કે રિસીવિંગ એન્ડથી સેન્ડિંગ એન્ડ તરફ જાય ત્યારે. એટલે એને કયું વેવ કહેવાય? ઇટ ઇઝ નોન એઝ ઇન્સિડન્ટ વેવ. ઓકે, ઇન્સિડન્ટ વેવ એટલે આનાથી ઓપોઝિટ લઈ તો સેન્ડિંગ એન્ડથી રિસીવિંગ એન્ડ તરફ જાય એને કહેવાય ઇન્સિડન્ટ વેવ. ઓકે, એટલે એની ડાયરેક્શન કઈ હોય? સેન્ડિંગથી રિસીવિંગ એન્ડ તરફ, બરાબર. ઓકે, કોઈ પણ વેવ હોય એ જ્યાંથી ડેવલપ થાય અને બીજી તરફ જાય એટલે એનું મેગ્નિટ્યુડ ઘટતું જાય. ઓકે, અહીંયા આપણે જોઈ શકીએ છીએ સેન્ડિંગ એન્ડે પ્રોડ્યુસ થાય, રિસીવિંગ એન્ડ તરફ જાય એટલે એનું મેગ્નિટ્યુડ ઘટતું જાય. અને ધ વેવ વિચ વિલ ટ્રાન્સફર ફ્રોમ સેન્ડિંગ એન્ડ ટુ રિસીવિંગ એન્ડ ઇઝ નોન એઝ ઇન્સિડન્ટ વેવ. ધ ફર્સ્ટ ટર્મ છે એ કોનું છે? ઇન્સિડન્ટ વેવનું છે. એનથી ઓપોઝિટ સેન્ડિંગ એન્ડ, બરાબર. ઓકે, ધ વેવ વિચ વિલ ટ્રાન્સફર ફ્રોમ રિસીવિંગ એન્ડ ટુ સેન્ડિંગ એન્ડ એટલે આનાથી ઓપોઝિટ. આ ઇન્સિડન્ટ વેવ અહીંયા જશે, બરાબર. અહીંયા થોડુંક રિફ્લેક્શન થશે અને પાછું રિટર્ન જશે. તો આ વેવ છે એને કયું કહેવાય? ધીસ વેવ ઇઝ નોન એઝ રિફ્લેક્ટેડ વેવ. ઓકે, સો ધીસ ઇઝ ધ રિફ્લેક્ટેડ વેવ ઇઝ ઓલવેઝ ઓપોઝિટ ટુ ઇન્સિડન્ટ વેવ. એટલે આપણું જો સેકન્ડ ટર્મ છે એ એક્ઝેક્ટલી આને ઓપોઝિટ છે ફર્સ્ટ ટર્મને. આ ઇન્ક્રીઝ થાય છે તો આ શું થાય? આ વેવ છે એ ડિક્રીઝ થાય છે, બરાબર. સો ધીસ ટર્મ ઇઝ રિલેટેડ ટુ ઇન્સિડન્ટ વેવ, ધીસ ટર્મ ઇઝ રિલેટેડ ટુ રિફ્લેક્ટેડ વેવ. ઓકે, ધ વેવ વિચ વિલ ટ્રાવેલ ફ્રોમ સેન્ડિંગ એન્ડ ટુ રિસીવિંગ એન્ડ ઇઝ નોન એઝ incident wave, and the wave which transfer from receiving end to sending end is known as reflected wave. Okay, and at any point the the sending end and incident wave and reflected wave is addition and make a traveling. Okay, these are the notes as I said you that in opposite as it move from sending end to receiving end. Okay, and it is known as reflected wave. Okay, here you can see the figure of incident wave. બરાબર, આ ફિગર છે ઇન્સિડન્ટ વેવની. લેટ્સ સે ધીસ ઇઝ ધ સેન્ડિંગ એન્ડ, ધીસ ઇઝ ધ રિસીવિંગ એન્ડ. ઓકે, જે વેવ હોય સેન્ડિંગ એન્ડથી રિસીવિંગ એન્ડ તરફ જાય અને એનું મેગ્નિટ્યુડ રિડ્યુસ થતું જાય તો એને શું કહેવાય? ઇન્સિડન્ટ વેવ. અહીં જો આ ફર્સ્ટ બ્લેક લાઇનમાં વેવ છે, પણ થોડીક વાર પછી ક્યાં જશે? આગળ જશે. એનો મેગ્નિટ્યુડ જો અહીંયા રિડ્યુસ થઈ ગયું અને ફેઝ કેવો થઈ ગયો? એની કરતાં એડવાન્સ થઈ ગયો. સો ધીસ ઇઝ નોન એઝ ઇન્સિડન્ટ વેવ. ઓકે, if you are not and if you are like to more get information about the incident wave and reflected wave, then you can visit the definitions of traveling wave. Okay, thank you. Now next topic is power flow through transmission line. Okay, now we will study the power flow through transmission line. Here you can see that this is a generator end, this is the load side. Okay, this is the bus 1, bus 2. Bus 1 is available at the generating side, bus 2 is available near the load side or receiving end. Here the power at generation side is given as SS equal to PS plus JQS. Here S represent the sending end. Okay, so S represent the complex power, P represent the active power, Q represent the reactive power. Okay, VS del, here VS represent the sending end voltage and del represent the phase angle between VS and VR. Okay, here in between the transmission line RLC will come. Okay, so that's why these both have not same phase. The difference is represented by del. Okay, so del is the representation of phase angle between the VS and VR. ABCD. Okay, here transmission line is available and transmission line is characterized by is ABCD parameter. So ABCD is represent the parameters of transmission line. Okay, here VR 0. Okay, this is the reference and voltage. Here I take the 0. Okay, 0 represent the reference value for phase angle. Okay, now SR equal to PR plus JQR. Here R represent the receiving end, so S is complex power, P is active power, Q is reactive power. Okay, here the receiving end voltage is represented as a VR. Okay, in magnitude it is represented like this: magnitude VR, mod VR, angle 0 degree. Sending end is represented as a mod VS, angle del degree. Okay, where the del is phase angle between the VS and VR. Okay, generalized constant ABCD are write like this in mod and with angle A alpha, B equal to mod B angle beta, C equal to mod C angle gamma, D equal to mod D angle delta. Okay, now receiving end power, okay, SR equal to PR plus JQR. Okay, we are starting derivation of equation from this point. અહીંયાથી start કરશો. Okay, from the receiving end power. I already said you that this represents the complex power, active power and reactive power. Another equation for SR is given as a VR IR star. Okay, VR IR star. This is the another equation for complex power at receiving end side. Here IR star represents the conjugate of R. Okay, so we will derive from this equation. So our aim is find the equation for VR IR star. Okay, now we will take one equation to find the IR. Okay, this is sending end voltage in form of equation of sending end voltage in form of ABCD parameter. You are already familiar with this equation. Vs equal to AVR plus VIR. This is the equation of sending end voltage in term of ABCD. Okay, now we have to find the IR. That's why we will make IR as here. Okay, so IR equal to Vs minus AVR upon V. Okay, just change the side, so IR will come like here. Okay, so Vs minus AVR divided by B. Okay, so this is the second equation. It is the equation of IR. Now we will put the value of this IR. Okay, we have the values of Vs, AVR, B that are mentioned here. Vs, put Vs equal to Vs mod Vs del, A equal to mod A alpha, B beta, C gamma, D delta, like this. Okay, so put all these values in equation 2. So Vs is represented as mod Vs angle del minus A angle alpha, VR angle 0, B is given by mod B beta. Okay, now this denominator will separate. Okay, so Vs angle delta divided by B. Here beta will go in denominator of delta, so del minus B will return. Okay, बीटा અહીં નીચે આવે બટ એંગલ છે બે એંગલ છે એટલે આપણને ખબર છે કે અહીં ડિવિઝન એંગલ હોય તો માઇનસ થઈ જાય. ઓકે, એટલે ડેલ માઇનસ બીટા થઈ ગયો. અગેન હિયર A divided by B, VR will, okay, and alpha will 0, alpha plus 0 minus B, so alpha minus beta. અહીંયા જો બંને એંગલ છે એ મલ્ટિપ્લિકેશનમાં છે એટલે એનું એડિશન થાય, અહીંયા ડિવિઝનમાં છે એટલે એનું સબસ્ટ્રેક્શન થાય, એટલે આલ્ફા પ્લસ 0 માઇનસ બીટા એવું આવે, બટ 0 ઇઝ નોટ અવેલેબલ, સો આલ્ફા માઇનસ બીટા. ઓકે, એ VR B કૌંસની બહાર છે, બરાબર, એંગલની બહાર હોય એનું મલ્ટિપ્લિકેશન અને ડિવિઝન થાય, ઇન એંગલ એડિશન અને સબસ્ટ્રેક્શન થાય. So from this equation you will get this equation. Okay, now this is the equation 3. Okay, now this is equation of IR. We have to find IR conjugate. That's why I find IR conjugate just simply beta minus del, del minus beta comes beta minus del, alpha minus beta comes beta minus alpha. Okay, so this is the IR equation for IR conjugate. Now put this value of equation in equation number 1, which is the equation of SR VR IR star. Okay, the value of IR put in this. Okay, so VR will multiply, so SR will give as a VR will come into the multiply and put this equation. IR star નું ઇક્વેશન આખું આની આગળ છે, VR હતો તો એ આ બંનેની સાથે મલ્ટીપ્લાય થઈ જશે, એટલે અહીં જો VR આવી ગયો, અહીંયા VR એક અવેલેબલ છે, અહીંયા બીજો VR છે, આનો મલ્ટીપ્લાય થશે SRનો, એ VR સ્ક્વેર થઈ જશે. ધીસ ઇઝ ધ ઇક્વેશન 4. ઓકે, SR, ધીસ ધ રિસીવિંગ એન્ડ સાઇડ કોમ્પ્લેક્સ પાવરનું ઇક્વેશન છે. ઓકે, હવે આપણે આની ઉપરથી એક્ટિવ પાવર અને રિએક્ટિવ પાવર ફાઇન્ડ કરવાના છે. કેમ કે આપણે આગળ જે ઇક્વેશન હતું એમાં જો SR ઇક્વલ ટુ PR પ્લસ JQR, એટલે PR અને QR ફાઇન્ડ કરવાના છે. ઓકે, હવે તમારે સિમ્પલી SR કોમ્પ્લેક્સમાંથી એક્ટિવ પાવર P અને Q ફાઇન્ડ કરવા હોય, બરાબર, તો એક્ટિવ પાવર ફાઇન્ડ કરવા યુ હેવ ટુ પુટ કોસ એટ એંગલ એન્ડ યુ હેવ ટુ પુટ સાઇન ફોર રિએક્ટિવ પાવર. સો એક્ટિવ પાવર માટેનું ઇક્વેશનમાં અહીંયા બંને જગ્યાએ કોસ આવી જશે, રિએક્ટિવમાં સાઇન આવી જશે, બરાબર. સો ધીસ ઇઝ ધ ઇક્વેશન ઓફ એક્ટિવ પાવર PR. ઓકે, ઇન્સ્ટેડ ઓફ SR we will write PR. VS VR B, instead of angle here cos will return, cos beta minus del minus AVR square beta cos beta minus alpha. This is equation 5 for active power. This is equation for receiving end power. Instead of cos, we will write sine. Okay, so it will convert as a reactive power at receiving end side. Okay, so this is the derivation of complex power and in form of active power and reactive power up to the equation number 6. Now we will consider one condition. Okay, condition for the maximum active power. Okay, in actual system it is most beneficial to make active power more than reactive power. Okay, so we will study one condition that is that active power is maximum. Now this is the equation of active power. Okay, we have to make it maximum. You know that to make, okay, first of all this equation is made from two terms. Okay, to make this PR maximum, you know that you have to make this term maximum. આ ટર્મને મેક્સિમમ બનાવવો પડે, બરાબર. આને મેક્સિમમ બનાવશો, બરાબર, તો આ તો આમાંથી સબટ્રેક્ટ થાય છે એટલે આ ઘટે. ઓકે, આને મેક્સિમમ બનાવવા આ ટર્મને મેક્સિમમ કન્સિડર કરવું પડે. ઓકે, મેક્સિમમ કન્સિડર કરીએ એનો મિનિંગ એવો થાય, ધીસ ઇઝ ધ કોસ, ધીસ ઇઝ ધ મલ્ટિપ્લિકેશન. ઓકે, એટલે આ એંગલ મેક્સિમમ હોવો જોઈએ. cos will also become 0, cos will also become 1. ઓકે, હવે અહીંયા આપણે cos મેક્સિમમ વેલ્યુ, cosની મેક્સિમમ વેલ્યુ છે 1, એટલે આ ટર્મ છે એમાં 1 થાય ત્યારે PR થશે મેક્સિમમ. ઓકે, this will become 1 when beta equal to delta. Why? Because cos 0 equal to 1. We know that cos 0 equal to 1. We have to make cos whole term 1. Why? To make it maximum. So we have to make this angle as 0. 0 will only occur if the beta equal to delta. Then b minus delta will become 0. So cos 0 will become 1 and PR will become maximum. So this is the condition to make active power maximum. Okay, and at that time the PR is written as a PR max. Why? Because it is the condition for maximum active power. Okay, so this is same. Okay, we have to make this term maximum, we have to make cos beta minus del to 1. So beta minus del both will become 0 or same, so that's why cos 0 will become 1. Okay, now PR written as a PR max. Okay, put instead of cos beta minus del 1, here cos beta minus alpha. Okay, same. So this is the equation 7. This represents the PR max equation. Same value you have to put into equation number 6 also. Okay, in equation number 6 you also have to put beta equal to del. Put here beta equal to del, then it will become 0. Sin 0 will become 0. Okay, cos 0 1 થાય, sin 0 0 થાય, એટલે આ આખું ટર્મ છે એ 0 થઈ જશે. આ 0 થાય એટલે આ મલ્ટીપ્લાય થાય એટલે 0, એટલે QR equal to minus AVR square sin beta minus del આટલું જ હોય, આ ટર્મ 0 થઈ જાય. ઓકે, એટલે એક્ટિવ પાવર મેક્સિમમ હોય ત્યારે રિએક્ટિવ પાવર હોય, અને અહીંયા QR મેક્સ રિપ્રેઝન્ટ કર્યું છે, but here this max represent the active power is maximum, not reactive power is maximum. Okay, so this is the equation number 8. Okay, this equation for active power and reactive power for the condition when the active power will become maximum. Okay, now another term is we will put A equal to 1 0, B equal to Z theta. Okay, previous topic is completed. This is the one new condition. Okay, પહેલી condition maximum active power ની complete થઈ ગઈ. આ second condition છે for normal transmission line. A and D are same and it is taken as a 1 0 degree, B is taken as a Z theta degree. Here alpha equal to 0, beta is taken as a theta. Okay, now again put this both value in equation 5 and 6. Here this is the equation 5 and 6. એટલે આ બંનેમાં આપણે પહેલાં મેક્સિમમ એક્ટિવ પાવરની કન્ડિશન પ્લેસ કરી હતી, બરાબર. એક્ટિવ પાવર મેક્સિમમમાં બીટા અને ડેલ સેમ હતા, આમાં આપણે આ વેલ્યુ ઇનપુટ કરશું, બરાબર. સો વી વિલ ગેટ ઇક્વેશન 9 and 10. ઓકે, ધીસ બોથ આર ઇક્વેશન્સ આર ફોર ધીસ કન્ડિશન. ઓકે, સો ધીસ ઇઝ પાવર ટ્રાન્સમિશન થ્રુ ટ્રાન્સમિશન લાઇન. પોઈન્ટ ઇઝ કમ્પ્લીટેડ. થેન્ક યુ.